question 18. So for A part 1, we're being asked to write down the points where the graph of y equals f x minus 2 crosses the x-axis. Now this transformation is inside the bracket, so it affects the x-coordinate but does the opposite to what you would expect. So it doesn't take away 2 from each of the x coordinates, it adds 2 to the x values. So the original curve f of x crosses the x-axis at 0, 0, 4, 0. So we're going to add 2 to each of the x coordinates. So no longer 0, 0, it's 2, 0, and no longer 4, 0, it's 6, 0. Now we're being asked where this transformed curve crosses the y-axis. Well, as we said earlier on, all the x coordinates are going to have 2 added to them. So if you consider this point, well, every single point on the curve is going to move 2 to the right. So this point here, which is presently minus 2, 4, is going to become 0, 4. So that's the point that would be crossing the y-axis, so 0, 4. Now for part B, the transformation is now outside the function. So this does 2 things. It affects the y-coordinate, but it does exactly what it says on the tin. So you add 2 to all the y-coordinates. Had, for example, the 2 be in front of the function, so 2 lots of f of x, you would be doubling all the y-coordinates. But because it's we're adding 2 to the function, we just add 2 to all the y-coordinates. So every single y-coordinate has to have 2 added to it. So no longer 0, 0 is 0, 2. No longer 2 minus 2 is 2, 0. No longer 4, 0 is 4, 2, and so on. So every single y-coordinate is shifted up 2. So the whole curve is just shifted up 2.